Does it work? Yeah. Well, we've just heard from Chris and from Jonathan's presentation before what is driving IoT and the adoption in general. The ability to drive new business model and to actually create differentiation into the market, first thing. Second, the ability to actually make your operation leaner and drive cost efficiency over the market that you're trying to address. And third, and not least, which was mentioned before, the ability to actually meet regulation. The next presentation is more about the two first one. Before e-commerce, you and I had to go down to the shop down the street to actually buy the goods that we wanted and or flick through a catalog and try to reach someone on the phone to get it delivered whenever it was actually feasible. E-commerce in the middle of the 90s has actually changed that habit and that behavior dramatically. I mean, one good example of the creation of Amazon in 1995 in a garage in Seattle has actually been driving e-commerce over the years. Today, e-commerce is $1.5 trillion. That's going to grow by 60%, or whatever the number you actually want to be. And this is going to change dramatically the way we actually do things. More importantly, the mobile part and the mobile aspect of these things is going to accelerate as well. A third today of those transactions is actually done through a tablet or through a smartphone. And that is supposed to actually grow 3 times faster than traditional e-commerce. Vodafone and Amazon have been working together over the last 5-10 years, and we've been really trying to help Amazon building their brand and actually getting into those markets. We've been working on the Kindle e-reader, we've been working on the Kindle Fire, their tablet, to create innovation. And there is no problem about the whole. It is actually clear. IoT and the relationship with telcos and the whole value chain will actually create benefits with firms and for firms like Amazon moving forward. Today, e-commerce is still only 7% of the whole retail business in the world. And if we wanted to actually grow and accelerate, there is no question that IoT will play a key role moving forward, which takes me back to the garage story at the beginning. The traditional factory and the traditional way of dealing with supply chain is being challenged. Automation, increased and leaner organization are being implemented, are actually making a real difference into the market. One of the leaders is Amazon Robotics, and it's my great pleasure to actually introduce you to Joe Durham, who is going to talk to us about how Amazon is driving their activity and implementing the next factory of the future. Joe is in charge of research and advanced development, and I hand it over to you.
All right, thank you, Tony. I'm excited to be here to tell you about what we do at Amazon Robotics. This will be a slightly different talk than the ones you've just seen, sort of a dive into how our warehouses are like a network of things, how they're a sort of an example of that. So I joined Kiva Systems a little bit before we were acquired by Amazon, and that happened in 2012. And so it's been fun to be part of the transformation of the company from that sort of late stage startup through the sort of new acquisition period, and now through our rebranding into Amazon Robotics, a sort of name change to signify our expansion of scope for what we do inside of Amazon. So let's take a look at these warehouses. Many of you, I'm sure, have bought things online, hopefully from Amazon. Before coming here, I picked up a guidebook for the beautiful city of Barcelona. And so the experience is you go online, you press buy, and then magically, shortly thereafter, the box arrives at your door, at your post office. So I'm going to give you a little peek behind the curtain today about what happens and the robots and the people and warehouses that make that delivery happen. So right after you press buy, your order sort of goes through a series of Amazon servers to decide which warehouse in the world, or I'll give some examples for the US, which warehouse we're going to use to fill that order. So we've already actually done an initial version of that so that we can make that promise on the website that you'll get it by a particular time. So we've done an initial version of like, well, we do have the inventory and it's nearby. And then there's a sort of final optimization of which warehouse we'll select. And there's a lot of interesting things at that sort of fulfillment network level, but that's a different talk about, you know, how to manage inventory across a country and regional differences in what people buy. But once an order is assigned to a warehouse, that's where our sort of robots take over. And so in this particular case, you know, my book for Barcelona, if it's available in a few different warehouses, it would be assigned to one near me in Boston, where Amazon Robotics is located. And then after the warehouse, it gets handed over to UPS or FedEx. What happens inside the warehouse? So a little bit of anatomy, I guess, for what our systems look like. There are a bunch of components. The main, you know, one that we get our name from are the drive units, or robots. These are two different sizes. We have a sort of standard size and then a pallet size robot. And they move around shelves, or pods, as we call them. Of course, being robots, they have batteries. They need to go and recharge. And then on the perimeter of the floor, there are stations where people do all the interaction with the inventory itself. And all of this is connected by Wi-Fi, right? This is our network of things. We have robots, we have shelves, we have chargers, and we have stations. And so they're all connected, and I'll talk more about the sort of server side of that today. All right. So to give you a deeper sense of how that works, we've got a little video stitched together from a couple of different sites. And to start off, we've got sort of these robots moving across. There's stickers on the floor that provide localization. That's our cheap solution for giving robots an idea of where they are in the system. But when we go to fill your order, first we decide, you know, which of those inventory carrying shelves are we going to pull for your particular order. Once it's identified, a robot's dispatched to go and get it. So this is a robot sort of moving unladen through the warehouse to go and find your shelf. When they don't have anything on them, they can slide underneath other shelves. We call that tunneling. So it's very easy for them to move around. They can just move underneath all the shelves to find the one they're supposed to be at. This is our corkscrew lifter. It sort of picks up the shelf. And now the inventory for your order is mobile, and we can deliver it anywhere in the warehouse. Once a drive is carrying a pod, of course, it's much more constrained as to where it can go. So it'll navigate through these blocks of storage on streets, come out to this sort of sortation area, if you will, where all these shelves are sorted from storage to the different queues for stations on the perimeter, like I was talking about. So it'll cross over this highway area and come to a queue in front of a particular worker. And this is our interface between the machine and people, and where the product's actually handled. So we spend a lot of time and focus on sort of maintaining this steady stream of shelves in front of every worker. Once a worker has picked out your product, we're done with the shelf, and it can go back to storage. We get to choose a new location for it. The robot will leave the queue, go back across that highway, and the system will select a new location for that shelf now that we're done with it. So robot will sort of navigate back to this new location. You can see here the sort of tight physical tolerances we have, right? There's only a few inches between these shelves as the robots are navigating between the aisles of storage. Once the robot reaches the designated spot, sort of unwind that corkscrew, lower the pod, and the robot's now free to do something else. It may go off and pick up another shelf, or it may need to go and dock itself into a charger. So we got one example of that here. So the robot will just sort of back in, plug itself in, start getting some juice so that it'll be ready to keep working. And it's on to the next thing. All right. So a little closer view at a couple of these robots. Like I talked about, we have two models. Same fundamental idea. Two powered drive wheels. They rotate in place, casters to provide stability. They can tunnel underneath pods, connect with Wi-Fi to the rest of the warehouse. And they have relatively inexpensive sensors. Cameras looking down to see those stickers on the floor I was talking about, cameras also for detecting obstacles if anything falls in the warehouse and they encounter it along the way, and our cheerful orange color scheme. So we hold all of our inventory on pods. There's a lot more sort of thought goes into it than you might imagine. These are designed for density and for durability. We optimize them for the specific products that a warehouse will hold. So this can include pods designed for clothing if it's a clothing heavy warehouse, designed to hold books, or designed to hold microwaves. Amazon sells everything. And so we have to sort of come up with a small number. We only want a handful of different designs, but those designs will fit all of the different things that are held in a warehouse and will last for decades, right? We want them to go through all of these cycles of lifting and lowering, being driven around for a long period. So people work at stations on the perimeter of the floor, and they're the ones that interact directly with products. So they'll pull it out for your order and pack it up. They also put the inventory back into the shelves and do things like count and inventory control so that we know what we have. To give you a sense of scale, each warehouse can have thousands of workers doing a variety of jobs, from picking and packing, stowing, managing the shipping dock, all of these things. Supported by many thousands of robots doing all of this pod movement and moving shelves around the warehouse. It can be tens of thousands of inventory pods across multiple floors in some of our warehouses. Holding millions of products. Amazon sells tens of millions of different things, and any particular warehouse will have some subset of that in the millions. To give you a sense of how far we've come and how long we've been doing this. The original Kiva production site started as a pilot in 2006 with just 30 robots. It expanded dramatically to 500 in 2007, and that one's been running ever since. Like I mentioned, Amazon acquired us in 2012, and our growth has significantly accelerated since then. As you can imagine, Amazon's scale is enormous. So if you sum up sort of over all of these drive missions, we have almost reached the sun in terms of total distance that our robots have traveled. And if my math is right, we'll get there right around Black Friday for the holiday peak season this year. So that's quite an exciting milestone for us. But getting back to the sort of how this is a network of things, our architecture started out with sort of servers in the building. Every building had its own local compute, local database, things like that. And so they were sort of a little network of their own of things, but they weren't connected in the same way that they are now. And because they had that on-site server, any upgrade required downtime, right? And once you say to a warehouse, hey, we have to take you down in order to get you this bug fix or some software upgrade, they'll resist because they want to keep running and they need to keep running. And so you get this proliferation of versions, right? This site hasn't taken that update yet. This other one is on a new version, et cetera, et cetera. So we've had a big focus in the last few years to move to the cloud. We use, of course, keeping it in the company, Amazon Web Services for our cloud services and databases. And it's much easier for us to scale and keep up with the growth of Amazon and the expansion of warehouses, and to sort of do continuous upgrades with no downtime. And as a part of this also, moving out of the warehouse itself into the cloud, we've had to design around latency and how to handle the communication timing. So I'll walk you through a little bit of what my team does in particular, sort of resource allocation problems of what orders are we going to do next. We've got a huge backlog, of course. People are placing orders constantly with different deadlines. And so which ones do we do now? Which ones do we wait a few hours? Which ones do we do tomorrow? Which ones do we want to do together at the same time? And once we decide we're going to work on orders, we look at which station should fill it, which pod, which drive will we bring over, and then also how to manage the battery capacity of the fleet, how to keep that fleet healthy and ready to keep working into the future. So when we're looking to decide, how are we going to do this order for Harry Potter? Somebody goes online, orders a particular book. Well, we need to decide amongst all of those outstanding orders and the truck schedules, when different orders need to be sent out the door, when we'll do it, which station based off of where the inventory is located. So that particular book may be on several shelves inside the warehouse. And we'll choose a station and then a shelf and then a drive so that that delivery is quick and efficient. And through this, we have to maintain sort of activities and a constant schedule for all of these actors in the warehouse. Thousands of people, many thousands of robots working together. One example about what I love about working with physical aspects with these shelves is how we can apply optimization ideas to the physical world. So one of those for us is how do we store shelves that have different products on them that are sort of moving at different speeds, products that get ordered with different frequencies. So we want to arrange the shelves so that the ones we need the most often are the easiest to get to. We store those up front. And so it's an online sortation problem. You have some current state of the world, this current state of that set of shelves, and an estimate of how frequently will we use every product that's on each shelf. And from that, we can optimize where we're going to put a pod down when we go to put it back. I talked a little bit about latency earlier and how it's something we need to design around as we move to the cloud. And so when you're making a request out to a service that's in the cloud, it can take 100 milliseconds or a few more, some fractions of a second to get an answer, depending on what the service you're asking is doing. And so what we do to handle that so that there's no delay for people or for robots when they are finished with a particular task is that we have a little queue of tasks for every agent sort of downloaded to them in advance so that when they're done with one, it's just right on to the next one. But there are pieces that can't be moved out. These are things like the direct control of equipment or identification of any faults. Of course, those have to be sort of local and right there in the machine. So as an example of this, when a drive unit is assigned tasks, it'll have what it's doing right now, which might be take a particular pod to a station, store that pod back at a particular location, etc. So it'll know only about that current task, and the system will have queued up the next one. And while it's executing that task, it will request paths or other resources it needs to complete that mission. So it'll ask the system, okay, how do I get there? So that our cloud server can decide how to route all these robots that are moving together through the shared space. Of course, it is not just robots, although that's my favorite part to talk about. People play an important role in keeping that system running. And it's another way that our warehouse is sort of a connected network. So we have tablet applications and stations and screens sort of directing every person to how they can play their role in the overall system. It includes things like monitoring the health of robots, pods, all of these pieces of the warehouse, and performance. And we can do that both through tablets and other things on site, and in remotely from anywhere, because it's all connected to the internet. And also coming out, as we've heard in some of the previous speakers, were talking about that amazing amount of data you get once everything is connected. Well, we get a huge amount of data from every robot, every mission, every shelf, every action that people take comes out, and that supports our efforts to continuously improve and make both our robots and people more efficient. So to summarize, so this was a view of how our robotic warehouses are a network of things and people that work together to deliver your orders. What's next for us? Well, we just completed our rebranding in Boston to Amazon Robotics, and so it's still very much day one for us. I have a talk tomorrow in a manufacturing session. I'll talk a little bit about the Amazon Picking Challenge. You see a picture up here. This is a sort of partnership or a contest we gave to academic researchers about direct object manipulation. We really enjoyed sort of that outreach effort. But being a part of Amazon just means a lot of growth, right? Every year, 20% or something like that increase in output, and a push to deliver things faster, which pushes the envelope on what we can do. So who knows where things will go and what our future holds, but I hope you enjoyed this sort of peek behind the curtain at what happens inside of our warehouses now. All right, I think in the interest of time, I won't take any questions, but seek me out if you have some. I'll be here through the rest of the week, of course. So thank you very much.